this video, we're going to be talking about stored procedures within SQL Server 2008 Express Edition. Stored procedures are a lot like methods in C# in so much that a method is a named block of code, right? It's the same with stored procedures. They're named blocks of SQL that can be called from other SQL or can be called using a .NET language like C# from within your applications. So we're going to answer the question in this video, why would you even want to use stored procedures? There's actually a couple of reasons. What I want to do first of all, start off by talking a little bit about how SQL Server works internally, and then I believe I can use that to make a case for why you would even want to use stored procedures. So each time that you run a query, a T-SQL query against your database, there's a little process that runs that has to parse that SQL statement that you wrote, figure out what you're trying to accomplish, and then create a plan of attack to determine the best way to actually retrieve the data in the most efficient way possible. So the developers at SQL Server at Microsoft, they spend a lot of time worrying about algorithms and storage techniques and whatever they can to improve speed. So when you submit a query that's based on the tables that you designed and the data types that of the given fields that you created, a little SQL Server program called the query processor first ascertains the approximate number of rows that are going to be returned from your query. It determines whether or not you defined indexes that could be used for this particular query, and if so, can they be leveraged to help improve the performance, and if so, how much? And so it creates this plan of attack called a query plan. So now all that happens actually in a fraction of a second, but still for the sake of efficiency, the query plan is stored in case you ever want to use that same query again, or at least a query that looks very similar to that query. Maybe it has different input parameters or whatever the case might be, but essentially it's pulling from the same tables and the same columns and so on. So if you really wanted to, what you could do within the SQL Server Management Studio is see a visual representation of the query plan. And so some really talented developers and DBAs, they'll often look at the query plans to determine why a particular query is not performing at what they believe to be top speed, and that might force them to make some adjustments and some suggestions to the query engine on how it could do its job a little bit better. So maybe the solution could be for the DBA to add an index to a given column, or rather create some metadata about a given column to improve the performance of queries that involve that column. We'll talk about indexes some other day. Or they could add some special Transact SQL hint syntax to their query in order to guide the creation of the query plan. But at any rate, just to be clear, no matter whether your T-SQL is written in the SQL Server Management Studio as an ad hoc query, or whether you're passing T-SQL directly from your C# code into SQL Server, or whether you're running a pre-compiled stored procedure like we're going to demonstrate today, in all those cases, in all those scenarios, a query plan is created. And in some cases, the query plan is cached, stored away for future use. However, the only way to ensure that the query plan is saved and to ensure that it's tweakable in all the ways that we talked about earlier is through the use of stored procedures. So that's the first reason that you might want to actually use a stored procedure as opposed to some of the other data access methods, is because there's some potential performance benefits. And I want to come back to that issue in just a moment because I want to emphasize the word potential one more time. We'll come back to that later. So the second reason that you might want to use stored procedures is to manage an application and user access to the data and to the underlying tables. So when we say that a database's job is to maintain data integrity, often users, the end users, are the enemy. Users can potentially change data that they shouldn't be changing, or perhaps applications might incorrectly be changing data. So database administrators, those IT workers who are charged with maintaining the database, they'll often protect the database tables, by preventing other users and other applications from accessing the underlying tables and data directly, instead offering only access to stored procedures for all of the typical create, read, update, delete operations on the data. So in this way, stored procedures can be used as a protective barrier between the user and the underlying data. So DBAs can then grant privileges to certain users to perform certain tasks by granting them permission to execute a subset of all the available stored procedures that might be available. So again, stored procedures could be used not only as a performance boost, but also as a way of maintaining control and safety for the data. Similarly, the third reason to use a stored procedure is to enforce business rules across the entire organization. So some database administrators and developers have determined that within their organizations, it makes a lot of sense for them to encapsulate business rules as close to the data as possible. So a lot of times, what you'll see in the books that you read and articles, they're written by C# developers, and so there's this ongoing struggle between the developer and the DBA. Instead of writing C# code to enforce business rules and allow multiple applications to share that C# code, some organizations, some developers and DBAs, instead make an architectural decision to enforce the business rules using T-SQL code in the form of stored procedures. And they may rationalize that there are many potential applications that will need the same data, and if you rely on developers across many different departments to use the same C# code, then it's possible that some rogue developer out there would find some workaround and the rules and the data integrity would become compromised. So again, combining this third reason of business rules with the previous reason of controlling access to the data, it makes a pretty strong architectural case for controlling who touches what data within an organization and how that data is used within the organization. So that's another way that you can use stored procedures. Fourth, it has to do with utilizing the best tools for the job. There's always been this, what some engineers call an impedance mismatch between C# that allows you to create the business rules and the Transact SQL for the actual data access. SQL is a language that was created to work with table-based data. Delegating all of your database table work to Transact SQL that is then nicely organized within stored procedures that are callable from C# makes a lot of sense for this reason. The problem is that C# and other programming languages have always been more focused on an object-oriented approach to working with data, which can be quite different from a relational database approach to working with data. So there, again, is that mismatch. There are some important nuances that oftentimes make working with SQL Server in a .NET programming language feel like fitting a square peg into a round hole, as the old expression goes. So over the years, a lot of effort, both on the part of Microsoft and third-party vendors, has been devoted to resolving this impedance mismatch between the relational and the object-oriented worlds. Most recently, the C# team, programming language team at Microsoft, added some SQL-like syntax and made it a first-class citizen of the programming language, and it's called LINQ. And there's a variation of LINQ called LINQ to Entities that we're going to demonstrate throughout the remainder of this video series. We'll begin looking at that on days 9 and 10. But at any rate, LINQ was added in C# 3.0 in roughly 2008. And has grown to become a popular technique for C# developers, not only to work with relational data, but to work with lists of any kind of data, whether that be arrays or collections of objects and so on. Still, the concerns of data access and business rules have to be addressed by each individual organization. So at a high level, there's good reasons why stored procedures exist and why they're so popular. Mastering SQL Server stored procedures is a vital skill that we're going to introduce here, but we're going to elaborate that on our other website that's devoted specifically to SQL Server and other technologies. You can visit that at www.trainingspot.com. Having said all of that about the value of stored procedures. Not all developers or organizations take this approach of putting all their eggs in the stored procedure basket. And this is a topic that's better suited for another day once you have more C# and SQL Server under your belt. But let me just say this. There are a lot of options for data retrieval and business rule implementation in the Microsoft world, in .NET and SQL Server and so on. And each of those options have their own peculiar set of trade-offs. So there's no one right way to architect an application. Despite what anybody else tells you, there's no one right way to do it. Now, there are a lot of wrong ways to do it, but there are a lot of options, viable options within the Microsoft world. So, to give you another side of the coin with regards to SQL query performance that I addressed a few minutes ago, we're going to talk about the entity framework and link to entities later on this week, but Microsoft's entity framework team insists that the queries that they construct on your behalf whenever you use the link to entities or other related entity framework APIs, in many cases are faster and better than the code that you'd be able to write on your own, especially as a beginning software developer. So one of the reasons why you might want to use SQL Server, or I'm sorry, stored procedures, because you think you're going to get this tremendous gain or benefit by using stored procedures over link code or ADO.NET or one of the other APIs I'm not ready to talk about just yet. That may not always be true. There might be another side of things that you have to consider. So things, I guess what I'm trying to say, are not cut and dry. They're not always so obvious in software development. My recommendation is that before you speak in definitive terms or before you get in an argument with anyone regarding which technology to use for a given project, learn that the only way to really know for sure these answers is through experimentation and learn more and not get too attached to any given paradigm. There are no easy answers when it comes to software development, and the only way to really get the best results is through an open mind, through experimentation with the various technologies, and through trial and error. So should you always use stored procedures? No. Should you always use link to entities or some other thing that we're going to show you throughout this series? No. Again, everything depends on the situation. I want to table that discussion for now. Got a little bit too deep into it, but just keep in mind that for now, each organization or development shop has to pick their own preference and technical requirements, and you as a developer oftentimes have to make some compromises from what you think or believe and in order to work with the team. We're going to pick that topic back up on another day. Okay, so we've laid all that groundwork. Let's go ahead and demonstrate how to actually create stored procedures. Let's see them in the SQL Server Management Studio, see them in action, modify stored procedures, delete stored procedures. And so we're going to start that in the next video. See you there. Thank you.